Ladies and gentlemen, boys and girls, welcome back to another, I guess this is a Monday edition of THAT.live. Thank you for coming. Before we get into the conversation, a few updates from our end. August 3rd is quickly approaching. We are only a month out from what's going to be an event of open spaces. So trying something a little different. You do need a ticket. Head over to tickets. Well, just go to thatconference.com. You can find us. But 30 days. So get your ticket. We're getting this stuff in play and we're getting ready to go. Today, I am talking with Guy Royse. I'm looking forward to the conversation we're going to have. Before we get there, though, Guy, how are you?
I'm doing all right. I mean, I'm getting a little scruffy. I'm rocking the COVID cut, but yeah, life's been pretty good. This working from home thing is actually really nice.
Yeah.
Kind of in it.
Yeah.
It's like I can focus.
Yeah. I do the work from home thing all the time. It's fun.
I do miss the travel a little bit. Last year I made it to Europe 7 times speaking at events, and this year I made it once, and so I'm a little disappointed in that. But first world problems, right?
Yeah, that's got to be quite the change.
Yeah.
So before we get into the meat of things, because I'm really looking forward to this conversation. But before we get there, can you just do a quick introduction as to who Guy Royse is?
Yeah, well, I'll start with the name, job title, and serial number sort of intro, and then just talk a little bit about stuff I like.
Okay.
My name's Guy Royse. I'm a developer advocate with Redis Labs, and so if you're not familiar with developer advocates, that means I speak at events, I create content, I do some training, I do kind of a mix of things, just a variety of activities. It's a great job for someone who has just the tiniest touch of ADD and is looking to monetize their narcissism.
There you go. I like that.
So that's what I do. I've been doing this kind of work for a few years now. I've been writing software for a lot more years than that. I've touched a lot of languages over the years. I'm lately been interested in, mostly my go-to language at the moment tends to be JavaScript. But I've been doing some AI stuff over the last couple of years, and so that requires some Python. I've done a ton of Java in my career, done some C# in my career back when it was brand spanking new. I even started out doing a little bit of COBOL at the very beginning, right out of college. So,
go to 100.
Yeah. And so I have done a wide variety of things in my career, and so I kind of fancy myself as a bit of a generalist, and which matches the ADHD sort of touch that I sort of described earlier.
Sure. So we were talking, I don't know, a couple days ago about a few different topics, and it was WebAssembly, graph databases, and a few other things in between. But I want to start at WebAssembly because it's not something that I hear a lot of folks talking about. So let's start there.
Okay. So
for those that might not know, what is it?
So WebAssembly is if you've done any kind of Java development or .NET development, you're familiar with the concept of the in .NET it's called the JVM, the Java Virtual Machine. In .NET it's called the Common Language Runtime. I assume it's still called that.
I would assume so.
And so these are bytecode interpreters or intermediate language interpreters, depending on your platform there. And so what you do is you write your software in a language of your choice, C# or Java or Scala or whatever, and then it compiles to bytecode, and then the bytecode interpreter will take that code and run it, and it will do just-in-time compilation and all kinds of optimizations. And it actually gives you a performance boost by doing that, because that just-in-time compilation that's happening inside of the Common Language Runtime or in the JVM can be optimized for exactly your microprocessor. Whereas before when we just compile C straight to a particular architecture and you wanted to just disperse it widely, you would have to, build a sort of a least common denominator compilation. So you couldn't take advantage of the instruction sets of advanced microprocessors. It'd run, but you couldn't get full capability out of that.
Sure.
And so that virtual machine paradigm model, whatever you want to call it, is actually ends up giving you a performance boost and gives you a lot of flexibility. So that's a virtual machine. WebAssembly is a virtual machine for the browser. And so it works exactly the same way. It uses a bytecode. It's a stack-based virtual machine, and you can write code for it in Rust. You can write code for it in C++. You can write code for it in WebAssembly text format, which is an assembly language, and render that down to bytecode, which can then be run by the WebAssembly runtime that's in your browser.
Okay.
And so that allows you to write compiled code that you can run in your browser, which is kind of cool, actually.
Yeah, right. And so there's a lot of things going on in my mind, and I hope we can dispel some of them. But I've been looking a lot at like Pika package and the new ESM stuff, and how Snowpack is trying to kind of reinvent. I shouldn't say reinvent, but like rework NPM, and it feels like we're at this like interesting crossroads of where there are efforts spinning. You have technology kind of moving along in a certain way where like we're advancing a bit, right? JavaScript has come a long way in the past, 10 years. Node's come a long way. We now got Deno and TypeScript has made its kind of indent into the world. So you have now you have WebAssembly, and you have, what's the other one I'm thinking of? With service workers.
It's not clicking for me. Sorry.
Yeah. Anyways, so the thing where you can run it all down locally. But anyways, so you've got the tech stacks that are happening. You've got the ecosystems that are changing. And it feels like WebAssembly is kind of at the root of it, or at the core, or could be at the core of it. I mean, are these things? Are these all kind of playing together tangentially in some way? Like, are we going to see them all kind of start to come together? Are these little building blocks of things, or is this like yet another cool thing we can do in the browser, and we'll kind of see where it falls out? I'm not sure if I'm asking my question right, but there's just all of these things which are, look like they want to build on top of each other, but aren't quite there yet.
Yeah, I mean, it sounds like the question is really, how does WebAssembly fit into everything else? Which is, I mean, that's a broad question, obviously.
I mean, you could say that about the web. Like, how does the web fit into itself?
Yeah. I think in some ways it's just going its own path. I know the WebAssembly work group. I watched a great YouTube video a few months back, and I don't remember who gave the talk or where it was at or anything. I just remember that the woman who was giving the talk, I think she worked for Mozilla. That's about all I can remember. And she was talking about plans for WebAssembly coming forward. So right now, WebAssembly is fairly limited as far as what it can do in a browser, right? It doesn't have a threading model. It can't do any kind of I/O. It can only interface. It's sandboxed inside of JavaScript. And so the way you interface with WebAssembly in a browser today is you write JavaScript code to instantiate this WebAssembly module, and then you call methods on it. So it kind of acts like a bag of functions. But you can also hand it functions in JavaScript that it can in turn call as well. And so you can do callbacks and that kind of stuff.
Okay.
And so it's just pure compute.
So can I interrupt though? Can you then deploy a WebAssembly with like the new ESM HTTP endpoints? Could you say, import endpoint, and that just happens to be this compiled WebAssembly? I don't know, what would you call it, a DLL? I don't know if that's a WebLL.
They're actually called WASM files.
Oh, okay.
For WebAssembly.
Okay.
And so they are literally just files that are sitting up there on the web server. And so if you want to use one, then you write JavaScript code to download that WebAssembly file.
Okay.
And then create an instance of the module therein.
Okay.
And then just use it. And so that's WebAssembly at its most basic.
Okay.
And in the browser, that's how it works. So it is literally, you download it just like you download a JPEG.
Okay.
And so it doesn't take over the web page. It's just it's a piece of a web page right now.
Sure.
The goal longer term is to try and turn WebAssembly into well, another thing you could use import with.
Right, right. That's where I was going with ESM.
Yeah. And so it would be nice if, you've got, this, it's like, well, we want to use React, and okay, well, import React into your WebAssembly module and use it. Or I build some, other, tooling to
Yep.
make life easier, and I just deploy it as a WASM module.
Right.
It's not there yet.
Right.
But that's the long-term goal.
Yeah, and that's the thing that I'm super excited about, because as the ESM spec has I don't know, recently been ratified to where you could do an import over a URL. If you try to like step back from everything and say, how could I reconfigure my deployment, my site, and all that to be able to take that on, it's a really exciting and compelling space. Like it becomes really interesting.
I think the big feature of WebAssembly, and I say this as a fan of JavaScript because I actually like JavaScript.
I do too.
And I'm probably going to make myself a persona non grata here by saying that I don't know what the big deal about TypeScript is. I'm perfectly happy with JavaScript. A pariah, that was the word I'm looking for.
I share your sentiment.
But a lot of people like TypeScript.
Yep.
That's fine. I've gotten very used to the very dynamic, loose syntax and the lack of typing. I actually kind of like it.
Yep.
And I fully own that as a stylistic choice.
Yep.
Right. I realize that a non-typed code base is actually more difficult if you inherit a legacy application and have to navigate it, it's harder.
Yep.
And so I acknowledge it as a bias.
Yep. I share your bias.
But one of the things that's ultimately you're still doing JavaScript even when you're doing TypeScript.
Yep.
And one of the things that WebAssembly gets is I feel like it's a JavaScript liberator. So all of a sudden I don't have to do it all in JavaScript for it to be in the client side. I can pick other tech stacks. And I think that's kind of interesting. And right now,
I never thought about that.
But if you're doing front end, you're stuck with JavaScript. And even if you do something to transpile it to JavaScript, you're still, well, the fact that we made up a word to talk about what that action is kind of means we're playing with something, right?
Mm-hmm.
We had to make up a new word to describe it, which means the JavaScript really isn't going away. And so, but WebAssembly makes the JavaScript go away. And so if you hate JavaScript and really want to build your front end in C, because who doesn't want to build their front end in C, right?
Yeah.
You know what I need in my front end development?
Right. Memory pointers. Yeah, I was gonna say pointers.
Yeah, pointers. Yeah, that's what I need. But I mean, you could do that. And so now it's not there completely yet, but it's moving along. That spec is trying to get a spec moved. Moving that spec forward is difficult. There's a lot of interesting challenges you got to solve. Like WebAssembly doesn't know what a string is, right? And you'd think that'd be fundamental, right?
Right. Yeah.
Except it's emulating a microprocessor and memory. And so, does a microprocessor know what a string is? Does assembly language know what a string is? C knows what a string is, but it has its version of it. So it's different languages are going to have different definitions of these basic concepts that make that really challenging.
So maybe this is the part I'm still missing a little bit. Who's the ultimate orchestrator? If we're talking about this in a browser environment, it's the browser then who is like delegating this somewhere to run outside of its, because it has its JavaScript engine and CSS parser and all of that. So it's the one saying, go run this in its own sandbox, I guess.
Yeah, that's exactly what's happening. Yeah, the browser is responsible for taking your bytecode and interpreting it, and then it can do all kinds of things to optimize that, but that's transparent to the user of it. Sure.
And then and again, this is me having not looked at it at all, is the bias in WebAssembly web related or just straight up compute related? I guess compute.
It's compute right now. They're trying to expand it to do to get DOM access, but that's without knowing what a string is, that's obviously challenging, and so it's just not there yet.
Right. And so if it had something like DOM access, then I guess my next logical question is, then is it the right tool for the job? Like, now that feels like you're like hitting a nail with a sledgehammer when all you needed was a simple hammer.
Yeah, it may not be the right tool for the job you're doing. It really depends on what you're doing. If you're doing something that's compute intensive, like say browser-based gaming, WebAssembly would be fantastic, because you get access to all that low. There's C libraries that can help you do that kind of stuff that you could you could just compile into it, which is kind of neat.
Oh, that's an interesting. I didn't think about that.
Yeah. I don't believe you'd have GPU access, but I don't actually know. But still, yeah, you do all kinds of interesting stuff like that. You can interact with the DOM indirectly. You can give it functions to call, and so you could write shim functions to go between WebAssembly.
Sure.
And like Rust has a library that does just that. For example, in Rust, you can they have a standard Rust library that you can use. What do they call them? A cargo module.
Okay.
In Rust that knows how to talk to a standard and expected JavaScript library from WebAssembly. And so then if you're doing a Rust app for client-side web, you have to incorporate this JavaScript file that's just for that. So basically you create a JavaScript library that knows,
it's like a physical callback.
Yeah, it's literally a callback, but it's a standard thing, and then you don't have to write it. They've already written it for you, and then you can just say from Rust, select DOM element and set it to foo, and do those sorts of things. So there are, wrapped up solutions for that. So you can, today with Rust, you can build full client-side application.
Yeah, it's
if you want to do that sort of thing.
Well, right, it's really crazy like that. It starts to really blur the lines of what should run on the server and what should run on the client, and then of course the hybrid models. And I guess I kind of live in this world every day where there are things that are better suited for the server because of how search engines and things, and natively want to get their pile of strings, but there are other places where just running on the client and interacting with the API is a better experience. And this really blurs that even more, because now if you do have the raw compute, then you're saying, well, yeah, we're now using the web as a deployment. And that's kind of crazy.
Well, and so I'm going to take it a little further with two more bits of data.
Yeah.
So one thing that you'll see, you've probably heard all the buzz around Blazor. Blazor is kind of a hot topic. What Microsoft did was they took the .NET CLR and compiled it to WebAssembly, because it's you can do. And so you've got a common language runtime interpreter, an IL interpreter inside of a WebAssembly interpreter. And so it's a little bit yo-dog.
Yeah.
But what it means is that you have a WebAssembly module that is .NET. And now all of a sudden you can run .NET stuff in the browser.
And that was the promise of .NET way back 10 years ago was, hey, here's this thing and we can kind of ship it anywhere. And now we're finally shipping it somewhere else.
I'd like to see the same thing for the JVM. I haven't checked in a few months, but last I looked, there wasn't anything. Probably because the JVM, the lack of threading would be a problem for if you tried to do it with JVM. The other thing that's interesting that's happening in the WebAssembly space is there's a command line virtual machine that's not browser based at all, called WASM time. There's a couple of these. WASM time is interesting. And it comes with a Clang extension so that you can just compile C straight to WASM time modules, to WASM modules. And so WASM time is just a command line WebAssembly runner. And they've created an interface called WASI, I guess, or WASI, WASI. It's the WebAssembly Systems Interface.
Okay.
So that you can do I/O. So it's kind of like Node for WebAssembly.
Okay.
So now you've got a server side virtual machine way of running this code as well. And so that means that you don't have to use any vendor specific, because there's no vendors behind this stuff. It's all open source. It's all
right.
It's all, the free software thing, right?
Right.
And so you can target that as well and run server side code. And I mean, this is all very new, and I haven't actually played with it yet. But now you can start doing socket
right.
connections and file I/O and standard in and standard out and all that sort of stuff, and run it inside of a WebAssembly runtime that runs server side as well. So you could actually use, so it's funny, right? So WebAssembly is it's for the web, and it's assembly, except it's not assembly, because assembly is a programming language that gives you machine code or bytecode. And then the web, so it's neither web nor assembly when you run it on the server.
Right. I'm trying to wrap my head around this in the sense that, I mean, I'm in the Node world every day, and now you have Dino or Deno or however they want it to be called. And
Dino is a purple dinosaur from the Flintstones, so I think it's got to be Deno.
Maybe. I hear everybody arguing about it though. And you have to ask, like, was Deno then, should that have just been WebAssembly? Like, does this unlock Node from V8 in a way that it should be? I mean, shit, I don't know. It seems like a new set of possibilities are coming that will change how we think about architecting apps, web apps.
It's a new tool. I mean, some of it is this is good foundational tools for building other things.
Yep.
Some of it is I mean, this could be the next iteration, right? Like when everyone started switching to server-side JavaScript, it was just a completely different thing from like if you're doing C# or Java on the back end.
Yep.
Right. It's just a completely different thing. And I'm sure a lot of enterprise IT departments screamed bloody murder because they didn't want to have to build yet another type of server.
Yep.
Then containerization happened, and then everyone stopped complaining about it. But
yep.
But I think this may be a comparable sort of change, where it's just another way of building applications that maybe it's just going to compete with JavaScript. But at the same time, it's playing with it. It's playing in a similar sandbox, pun not intended.
Right.
And so, I'm not sure where it's going either. I just think it's kind of neat.
Mm-hmm.
And I have a soft spot in my heart for like low-level languages. And so I actually will. I have a talk where I've coded live in the WebAssembly text format, so it's an actual assembly language, because it's kind of so I kind of like this kind of stuff. Right? It's really fascinating, but it becomes sort of a portable virtual machine type of thing, and people are talking about using it for edge computing and using it for IoT and right where we don't want to put a full-fledged VM.
Right.
Like a really big beefy one, but at the same time, we don't want to just, have to write everything in C and run it in. We want our C code to be multi-platform.
Right.
And so we spit WASM modules out and put them in lots of different platforms. And so I see people talking about those sorts of architectures, and they're still working on the standards. So who knows what's going to happen?
Yeah, it's interesting. I'm glad we've talked about it some. Should people go run out and look at it and start worrying about it now? I don't know. Probably not. Should people be aware of it?
It's a little cutting.
Certainly.
Yeah, it's a little cutting edge, but it's cool. And so I look at it from I just enjoy looking at it point of view.
Yeah.
It's just interesting.
Yeah.
And I realize there's a limited amount of cycles people can dedicate to things that are interesting, because there sure are a lot of interesting things out there.
Sure.
But I think it's worth checking out a little bit just to understand how it works. And because I think it is going to impact things. If you're a Rust developer, then you probably know a lot of this stuff already, and this should be something you care about. If you're a C developer, this is, just another way to do C. It's as languages get broader and broader support, I think that's where it's going to get really interesting.
Yeah. And this is, in some regards, if you step up a few notches, this isn't really anything different than things people have been trying to do in the past. I mean, Go's meant to run cross-platform and do this, and the .NET CLR, and these types of efforts have certainly, the JVMs have certainly tried to tackle what it sounds like this is tackling but yet a different way. So,
yeah. Well, and it's got the advantage of not being from any one company, right? I remember when Go first came out, or no, it was Dart.
Dart. Yeah.
And they were trying to get everyone to, Google was trying to get everyone to adopt a language, and none of the other big tech companies are going to do that, because they, if you're following, you're not leading. Right. And so in some ways it was kind of doomed.
Yeah.
Whereas something that comes out of the open source community as a standard can get wider adoption, because everyone can adopt it without, in essence, losing face.
Sure.
As a company. And so I think that's probably some of the reason why we're starting to see this one work, is because it's grassroots.
Yeah, I feel like in the web space we seem to have better momentum around pushing it forward. I think we got super stagnant for a while, but now it seems like I don't want to say the community or the company. It seems that there's just a high degree of just keeping the foot on the gas, and that's welcomed. I appreciate it. Although, that means there's a lot of stuff to continue to learn, which isn't a bad thing either.
Nope, never stop learning, right?
That's right.
That's the cliched thing you say in response to that.
That's right. Yeah.
Yeah. In some ways, for me, WebAssembly is a bit nostalgic.
Okay.
Because I cut my teeth in the '80s learning how to program as a kid on like the Commodore 64.
Yep.
And I learned how to program the 6502 microprocessor in machine code.
Okay.
Which is a fairly simple microprocessor. And so that kind of stuff is, that low level stuff was always kind of fun. And so WebAssembly, when I get low level with it like that, has that same nostalgia to it. It's reminds me of being 16 and I don't know, whatever you are when you're 16.
Well,
you're a lot of things when you're 16, aren't you?
Yeah. I'm going to say, I had a 14-year-old son. He's a lot of things at the moment that he's trying to figure out.
Yeah, I have 3 sons myself. They're all teenagers.
Yes.
My oldest just moved out a few weeks ago. So yeah, I got a good idea how teenage boys work.
I'm remembering what I was as a teenager. And I don't know if I'm happy or sad that I'm remembering how I was as a teenager.
I suspect if you didn't regret anything you did as a teenager, that you probably didn't do it right.
Yeah. It's total sidebar on all this, and I'm sure you and some of the others who are in here, I don't know that I'd want to be a teenager today. It seems a lot, it's drastically different. I feel like the room for making mistakes is there. The margin is very little, which seems kind of daunting when you think about it. Because I was a teenager. Like, there's a reason you kind of stereotype it. You were a teenager. Like, you did a lot of dumb shit. Like, yeah, you were a teenager.
Yeah. It's a good thing you can't get tattoos as a teenager, because you would have gotten dumb tattoos.
Right. Yeah, I had the conversation with my kids, like, they're on creating their, email account, whatnot. I was like, okay, let's not create the dumb one. Let's create the one that you won't regret in 10 years. Oh no, but I want this.
Last name @gmail.com.
Right. Let's keep it simple. All right, I want to switch the conversation a little bit. I'm curious if anybody in the chat, speak up. I'm curious if you've done anything or curious about WebAssembly. It's certainly meant to be an interactive conversation, but being that it is so new, I am curious. But I want to talk to you about graph databases.
Sure.
For those that know me, know I've played in the GraphQL land a lot, which has no bearing on a graph database. So we're just completely, taking a hard right turn and going down to database land.
Well, you might be able to implement graph databases in WebAssembly. That would be interesting.
Well, okay. I mean, you say that funny.
They're for a sec.
Like, I mean, to think about having a web app that maybe did have your own local database that you could do something with it, like that's pretty badass. Like I could see that as a thing.
When I first joined Redis, I actually looked into. I had this idea. I was like, we could compile Redis to run inside of WebAssembly. That'd be neat. And I Googled it, and someone had tried it, and and it was didn't perform very well, just because it's kind of a tiny. Let's run it in a browser and a little postage stamp.
Sure.
Right? And it didn't really add a ton of value that an in-memory database isn't very useful in the browser when you just have JavaScript there.
Sure.
But yeah, you could actually do all kinds of stuff like that, client side or even on the edge, or there's lots of ways you could do it.
So graph databases. Let's start with what is it? Why is a graph database different than other databases?
So a graph database is, I like to think the difference between a graph database and a relational database. We'll compare them to relational databases because those are the ones people are most familiar with. And there's an irony in the naming there. So in a graph database, because graph databases are all about establishing relationships.
Right. Yeah, I got the joke.
Whereas in a relational database, you get relationships between types, but you don't have relationships between the data itself.
Right.
And so, which is just different. So a graph database is based off of graph theory, the mathematical idea of graph theory. And in graph theory, you have vertices and edges. And so let me see if I got. Let me grab something here real quick. I'll grab my my model of a graph, a mathematical graph. So it's right here.
Okay.
Lighting's good.
Yeah.
So we got this nice giant red D20. It's a little dusty actually, which means that I'm not gaming enough. But so your vertices are your points right there, right?
Okay.
And your edges are the edges.
Okay.
Right. And so you can represent all kinds of things using graphs, and they don't have to make Platonic solids. They can make, shapes that you can't create. They're just nodes and relationships, vertices and edges. And so you can use this as a data structure. And the idea is that the nodes are essentially the nouns, and the relationships are essentially the verbs.
Okay.
And you can create structures that are that basically kind of act like sentences with transitive verbs. Mm-hmm. So a classic example that's always used for explaining graph would be a social network like Facebook.
Yep.
And so in Facebook, you'd have a user, and they'd have a name, and they would be friends with someone else. And so you end up with this web of this user's friends with these 50 people, and excuse me, and that person's friends with different people. And so the friendship, that relationship, is the edge of the graph, and the noun, the user, is the nodes. And so you end up with sort of these circles connected with lines.
Yep.
To sort of represent this.
Yep.
And in a graph database, that's how it stores all of its data. And so relationships are central. You're relating the data to other pieces of data as opposed to relating the types to each other.
Yep.
And so the nodes can be of different, have different labels. You could have a user node, you could have a message node, or a post, or a comment, or a like. A like would be a relationship, right? So
yep.
user wrote, post, user liked post.
Yep.
And so you create this very complicated graph that represents all this data. And well, that's in essence what a graph database is. And the cool thing is that you can do queries that things like, give me from this user, find all the paths in the graph that match this particular pattern. So user who has messages liked by a person. So you go user to person to liking a message that goes back to the user. Or I guess there'd be a couple ways you could path through that, but you can create queries that then represent that path in that graph. And you can create queries that will do n number of hops where n is unspecified. So if you created a graph of, say, the roads in a city, where, say, maybe the intersections are the nodes and the roads themselves are the edges, you could find a path. You could find the shortest path that way.
Okay.
Because it would match on the shortest path. So graphs are good for that kind of data. And
so you say that kind of data. So here's the things. Here's what stumped me about graph databases. 1, why aren't they used more? 2, why are they so flipping expensive? 3, why are they not everywhere already? They seem to be highly relevant. I think they can be used a hell of a lot more than they are, but yet obtaining them seems so left field that it feels odd. And that's just me standing from the outside. It's like there's only a couple of vendors. You gotta have a really, really deep investment. But then I stand back and I'm like, well, why is that? Like, I feel like this could be in every single app that's out there today in some capacity, and yet it's not.
I actually kind of agree, because it's a very natural metaphor that you could use for lots of problems. I feel like it's almost it's like going into OO from procedural programming. Like, OO was sort of like programming around nouns, whereas procedural programming is programming around verbs.
Yep.
Well, actually, it's really more programming around hierarchical decomposition.
Sure.
And functional, maybe that's more verbs.
Yep.
But regardless, analogies, they're like metaphors. When they break down.
I mean, my thing with databases is you could spend all the time in the world and you could design out this thing and whatnot, and you could think you've got it nailed and licked, and then you'll roll the production, and then a month later, by far, you screwed it in some way. And now you're stuck with all this data that you had to, care and feed and move and restructure, and however kind of seems to get there. And it feels like graph in some regards, I don't want to say solves that, but that's not as big of a concern.
Yeah, because if you add a new type, you just add a new type and the graph takes it.
Right.
It doesn't care.
Right.
It's like, hey, I didn't know that we were going to have this feature for, we had likes, but now we're adding, other emojis.
Right.
Just add new relationship types.
Right.
Done.
Oh, yeah, right. Look, I have a new relationship all of a sudden because my business grew a little bit.
Yeah. And so that's fairly, it is more flexible. There are gotchas. Like if you try to model something that's a relationship that should be a node, converting from a relationship to a node is kind of a pain in the butt. I've been working on a pet project on Stream called Redis Mud, where I use a graph database to represent a dungeon.
Okay.
And so nodes are the rooms. And my initial thought was the connections, the relationships would be the corridors connecting them. But then I realized I really needed to have doors be a separate object because it was another noun. And converting from that was a kind of a pain in the butt. But yeah, it is it's a very natural, once you start working with it, it's just really intuitive. And the query language used with Redis Graph uses it and Neo4j uses it. It's called Cypher. And it's like a combination of a query language and ASCII art. It actually looks like the pattern you're trying to match. It uses prints to represent the nodes and a little dash with square brackets and a little arrow pointing to the node it relates to. Okay. Right. Yeah. So it kind of looks, it looks like what you're doing. So it's all really, it's kind of elegant. And so it's a natural thing to want to use. the answer to that question is a lot of the graph solutions out there. Graph is there's a couple ways to model it internally, and neither of them are particularly efficient.
Okay.
And so that's been the problem. Scaling it's been hard.
Okay.
And I'm going to try not to make this sound like an ad for Redis Graph, but but Redis Graph has solved some of this problem, which hasn't been done yet, and so it's actually kind of in a unique position. So the two ways of storing data in a graph that have been used traditionally is you can use adjacency lists, where you basically start with every node in the graph. You have a list of nodes that it connects to,
Okay.
that it has a relationship to, and so it's just a linked list for every node. And so when you're walking to find things and to query that graph, you're walking a lot of lists. And so you get a lot of O of N operations.
Okay.
And so that's not super performant. As that list gets bigger, that just becomes more and more expensive.
Sure.
And so now it's nice and compact. It stores it nicely, but it's compact. The other way is you can use sparse matrices, where basically you've got a two-dimensional table for each type of relationship. And you know, remember on the road atlases in the back, they'd have the distances between cities, and you could look for cities on one side or cities on the other side, and then they would show the relationship, and you could look at it from either direction.
Yep.
That's what an adjacency matrix is.
Okay.
It's showing every node and every node. Is there a relationship 1 or 0?
Okay.
And the problem with that is that it takes up a crap ton of space, and it grows geometrically, right? Because every single time I add a node, right,
rework it.
And so it's fast, but its space grows really fast. And so both of those have resulted in either lots of memory or lots of compute or something like that. And so they've mostly been used for analytical databases more than operational databases. And so Redis Graph actually uses a different technique and I don't really understand it very well, but it's called a sparse adjacency matrix, where it's sort of like an adjacency matrix, but it only stores the ones, which sounds like that couldn't work, but there's some trick to it. And so I don't fully understand the structure. And then there's Graph Blast is a library for turning these into these matrices into linear algebra problems. And then you solve those, and it's optimized for that kind of thing. And so we're able to get some performance out of it.
Sure.
And so that's how Redis Graph solves that problem. And so that's the one I've been playing with because I work for Redis.
Hey, let me go back to my first comment. Graph databases are expensive.
Yeah. Well, then that sort of answers why they're expensive, is because it's a hard problem to solve, and they just require a lot of resources. I mean, as far as like buying the software, I mean, Redis Graph is open source. You can go out but it's using the Redis source available license, which basically is saying, use this in your company, use it for whatever you want. You just can't turn around and sell it as, look at our graph database solution you can buy as a service.
Right. Yeah.
Other than that, right? But it's been fun to play with. It's growing. It's not as feature complete as like Neo4j is, but the performance is really good. But even with Redis Graph is kind of compute intensive, and so if you do complex queries, they can sometimes take a while to resolve. In Redis terms, it's still, it's like it takes milliseconds instead of being sub-milliseconds.
Yeah, sure.
But I mean, we've had some benchmarks where if you scale it up, it's like, well, this took about, I can't remember the numbers, but it was upwards of a second to resolve some of the queries for particularly difficult queries. But it's something you can play with if you want to play with Graph, and it's easy to set up and play with.
Yeah, I actually didn't realize that Redis had a Graph implementation.
Yeah.
I knew of Neo, and I know there's another one. I can't remember off the top of my head.
I'm sure if you say it, I'll know it, but I can't remember all the other ones off the top of my head either. But yeah, it's a good one to play with. It's easy to get started with. I actually just use a Docker image and bring it down and start playing with it.
You say that like that's a bad thing. Like you just said, hey, I could just install this from Docker and be done, Docker Hub, and just be done and be up and running. I like that path. I like that path.
No. I didn't mean to say that like it's a bad thing. It's actually a great thing. Yeah. Actually, I use a Docker image called Redis mod.
Okay.
Which is Redis with a bunch of common modules tacked into it. Graph is one of them. So
I actually just searched for graph database implementations, and I got actually more than I was expecting to. Amazon's got Neptune, Infinite Graph. There's probably 15 in here. MarkLogic.
Yeah.
I don't know how SQL Server falls into that, but
well,
I might want to double check this list.
Well, it's also possible that GraphQL and Graph are getting conflated by the search engine.
Well, people have made that a nightmare.
I don't know. Yeah, just speculating.
Have you seen FaunaDB?
No, I haven't.
Okay, so Fauna, their claim is they're like the first serverless database, but they allow you to do this. I'm gonna destroy this. But rather than picking a model, be it relational or document, you can have this hybrid of any of them. Now, I don't think that they support graph, but the way they let you model your database in their database in there is that model your database in their database is pretty neat.
Is a multi-model database.
Okay.
That's what Redis bills itself as.
Okay.
So they have probably shown up in our competition channel on Slack.
I got you.
Have fallen on my head.
Okay. Yeah, I guess.
So I don't know anything about them.
Okay.
But yeah, you should check out Graph in general. I mean, it's really cool. I actually have some stuff up on screen if you want to see it.
Yeah, we can do it. Let's see.
I can happy to share my screen.
If you share your screen, let's see what happens. Go.
Okay, how do I share screens on Skype?
There's a little.
This guy right here. No, that's not it. There, I have a mic.
It's the two. It's the two little squares next to the heart.
There we go. And we'll share this one. Start sharing. Now we should have infinite U.
Got me. Okay, give me 1 second, and I gotta plop your desktop.
My stream is saying that there's a network error for me, but that could just be me.
Hold on. NDI. We can do this.
Okay, I'm back. There we go.
Desktop. Hold on. I think we can make this happen. Shared screen is me on me on me. And then we do this. And then people are like, whoa, Clark just made the internet.
Whoa. Ew. Let's bring up.
All right, oops. Why did it do that? Don't do that. That, folks, is what you call crazy sauce. There you go.
By the way, when I look up, I'm looking up at my other monitor to watch a 5-second delayed version of
of me completely reconfiguring things. Here? Yeah, look at that. Look, I got it. Yeah. We did it.
We're not just doing things on the fly. Right. We're agile, right? so
yeah. Can you bump your screen just a little bit?
Embiggen it there. Is that good? A little bigger.
There we go. And I got rid of the echo.
Excellent.
Good. There we go. Got it.
Cool. So everyone can see my screen.
Yep.
There's my cursor right there. Okay, so I've actually got a couple of little graphs here, and so that I've created already. But I got one that's a little family graph, and one that's called Spacebook. And Spacebook was a bunch of It's like Facebook for mid 20th century science fiction authors.
Okay.
So it's got, Frank Herbert, Arthur C. Clarke, Isaac Asimov. They're all in
Okay.
there, right? And so the easiest thing you can do in graph is it looks like this. So you say match, and then you want to match a node. And so you see it's inside of curly braces there,
Yep.
or parentheses. That means it's a node, right? And then you've assigned it to a variable n, and you can return it. And if I just run that query,
So this is like
then
the
we'll
select all of relational.
yeah, it's a select star from
Yep.
exactly. And so here's A. Asimov, not Isaac Asimov. Robert Heinlein. There's yeah. So the green ones are the users. Redis graph just, this is how it displays it visually. So you see the follows relationships there. Robert Heinlein wrote a post. This is of type. What type is that? Comment.
Oh, that's amazing.
And then there's a mention and wrote and replied, and you get the idea, right?
Yep.
So these are our nodes. These are our edges, then, or the vertices, edges, nodes, relationships, whatever you want to call them. I tend to say nodes and edges because they're both easier to say. And so to match them on this graph, you just say match, and that will match all nodes and return n.
Mm-hmm.
Now, if we look at this from a table view, all we're going to get back are the nodes.
Okay.
We're not going to get the relationships. The little graphical view goes ahead and shows you those relationships because it's convenient. So if, let's say, I wanted to say match all of the users, so I match all nodes of type user. So if we take a look here and say green is a user, so that's their label.
Yeah.
And then return U. That will return just the users.
Mm-hmm.
All right. And if we look at that in a tabular fashion, we just get all the users, and they all have names. And then there's a couple other things in there. Bob the Barbarian, from something else I was working on.
Okay.
So you can see how this is sort of like, kind of looks like what it is. You can extend it further and say match user, and then in curly braces, name, colon, r dots. We'll do A.C.Clark, since your name is Clark. And then that should just return Arthur C. Clarke. And I did it wrong. Is it square brackets? Might be square brackets. Oh, no, I didn't close the curly brace. There you go. So now we get just that one user, Arthur C. Clarke. If we look at it tabular, we just see Clark. Now, Redis Insight, which is the tool I'm using here to query Redis, if you double click on it, it'll show its relationships and it'll let you walk the graph, right?
Mm-hmm. So which
is kind of cool.
Yeah, it's amazing. So it's building, fair to say, subqueries of that main query then?
Probably. I'm not exactly sure what kind of query it does. I haven't looked at the internals of it. I just know it works. But that's probably what it's doing.
Yeah.
I could do a monitor in Redis and find out. But so you see here, we're saying match a user with attributes.
Yeah.
But you could also say match a user with a relationship of follows. So we'll do U2 and U1. And so then you see how this looks like. Take a user here that follows another user.
Mm-hmm.
So, and then I could say return U2, and that would return all the users that are followed. Which would be all of them. Or I could return U1, which is all the users that follow people. I could also just return their names if I want. And then I get just a list of all the names. And so this is actually a rather interesting query language, right?
Yeah.
it's like, who all does Isaac Asimov follow? Right.
Yep.
And so I could say, name A.Asimov, even though it's I did it wrong. And all the users they follow and their names. So now I've just queried that Isaac Asimov only follows A.C. Clarke. So it's kind of cool language, actually, because it looks like what it's doing.
Yeah.
So it's like ASCII art. And I just think it's kind of cool.
Yeah. I totally dig on it.
Yeah. And so when you do like the select all, match and return n, I mean, you can see how this is like, you can see how something like Facebook could use this, and it's just a really natural way to think about it. You're literally saying,
yeah,
select all the users, match the pattern in the graph. That's what you're doing.
Yep.
And then you're assigning parts of that pattern to variables, and then you're returning whichever part of the variables you want. You can also delete them. If I wanted to say, let's go to something that doesn't matter, my family. And, and so here we've got a very sophisticated graph of my wife being married to me.
Yeah. Okay.
Right. Very, very complicated, sophisticated graph.
That's right.
And so I could say match and delete and
only for testing purposes.
Yeah. And now I've deleted 2 nodes in one relationship. And if I go and query it, there's just nothing in the graph. I can also do creates, and say creates, n colon stream, type stream. And I believe you set name equal THAT.live. And let me put that all uppercase so it's properly branded.
Oh, there you go. Gotta hold out on those trademarks.
Yeah. And then, oh wait, I think it's on create. Oh, well, we can do it this way. Like that.
Missing a curly. There
It's
you go.
so easy to miss that curly
Yep.
brace. Right. So now we've got a node in the graph. And so you can do creates and deletes and all kinds of things. And it gets very sophisticated, but it's cool, right? And here's our execution time in milliseconds. Yeah.
So would you create? So then you could create, I guess, given the right kind of use architecture loosely, but you could create nodes in the graph dynamically then, right?
Create nodes dynamically in what sense? I'm sorry.
I was just trying to think, like, if you had I'm really pulling one out of my ass here, but if you had some, like, I'm thinking of like a Clubhouse or one of those like tools where you kind of create the foundation, but then you want to let the user like augment their experience a bit, where they have, maybe their own, data types of how they think of their project or delivery or whatnot. So they, in a sense, have this very abstract, loose type of, like, you could do a thing, but if you could create those nodes dynamically, then even though you, the product person, created this kind of abstract thing, you could still give them a very rich experience under that.
Yeah, I think I follow where you're going here. Are you thinking like sort of like software packages people buy and they want to extend them for their particular business needs?
Yep, essentially.
And because they have some type that you didn't anticipate, or their type was a little more sophisticated,
sure,
and had some
yeah.
extra property.
Yeah, I mean, I guess you could have overlaid it with some like crazy CRM, right? And
yeah,
they, hey, do whatever you want to do. But the power being in the graph side of things, like, right, in a Mongo sense or another document DB, right? There's just other JSON documents that whatever, right? Who cares what the fields are? Yeah. But in this case, if you could create them dynamically, now you can actually start to show the relationships of how things work. Now it's not just data, right? It's a hell of a lot more powerful.
Yeah, because it's the data with its relationships, and that's why I think it's ironic that relational databases are called relational databases, because graph databases are relationships play a much more significant role in them. In a relational database, you're relating the types.
Right.
A user has
Right.
posts.
Right.
Here you're saying, well, I've got some users and maybe they have posts and maybe they don't, and maybe they have other things that I haven't thought of yet.
Right.
And if you add a new thing, you just add it.
Right.
Whereas if you're using a relational database, it's like, oh crap, I didn't think about that, and now this relationship is no longer a one-to-many, it's a many-to-many.
Right. Right.
In a graph, they're all potentially many-to-manys, maybe, sort of, it doesn't matter. They're just related because this piece of data is related to this other piece of data. And then you end up creating these sentences with transitive verbs where, like, Guy is married to Linda.
Right. Right.
Or Guy married Linda, or however but they make these nice, neat little verb sentences, right? And which I think is kind of cool.
So if you're Facebook, then, I mean, I can only assume that they have a graph database on the back end. And you made this comment earlier that they're typically used in analytical senses, which I immediately went to kind of, they get primed once a night from the data, or once a week because they're expensive, and then we use them. We don't really use them at real time.
Yeah.
I would have to, I've long thought that Facebook uses a graph database as their implementation, but maybe I'm thinking about it wrong. Maybe they have some database that's kind of pointed to yet another database. So I guess my question being, how are people using them in conjunction with other databases, given their time, money, expensive, or are they using them as a standalone thing where that does have the authoritative data?
Yeah. So I'm going to speculate because I don't actually know.
Okay.
But specifically about Facebook, I know one of the things that you can do with a graph database is you can count how many paths match to a particular user. Like, so if all these people that are one hop away from you have someone that's another hop away, that is 2 hops away from you. So the friends of your friends,
Mm-hmm.
or the friend of your friends, is probably your friend as well.
Mm-hmm.
And so you get sort of this little diamond pattern, right? Where, here's me, and then here's my 2 friends, and there's a third friend down here that they have that's mutual. And the wider that diamond gets with the more people that are related, the more likely you are to know that. And so I wouldn't be surprised if Facebook is using that to do sort of running that periodically in maybe in localized chunks around a particular user, and then using that to generate recommendations that they then feed up in another fashion. Just because of their scale, right? Because you couldn't take all of Facebook and put it into a single graph. That would be insane. And so, but I'm sure they're using in a spot, in sort of a spot capacity like that. It'd have to be.
Well,
I think that's the only way to get it to scale.
So the internet seems to say MySQL is their primary database.
Okay.
For structured data storage, such as wall posts, information about various users, timeline. They use HBase, popularly known as HydraBase. This incorporates SMS, chat, email. Yeah, that's what we need, more email. Cassandra. Not sure. Doesn't really say. Then they use Haste.
I'm sure they're using Redis in there somewhere too. I'd be very surprised if they weren't.
It says Haystack and then Memcached.
Oh, okay, maybe they're not.
Hey, Facebook, why don't you use Redis?
They probably are using it in there somewhere. It's open source, so a lot,
Yeah.
Lots of companies use it. So.
Yeah, how does that work? How does that, you being something...
I'm going to bring it back.
What's that?
I'm going to stop sharing my screen.
Oh, okay. So. You mentioned, Redis being open source and lots of companies use it, and thus lots of companies use it. How do you find that? How do you find supporting that?
That's not really what Redis Labs does. Uh, Redis Labs has an enterprise version of the product.
Okay.
So it's a software as a service, database as a service. That's if you want to use Redis and you need to scale it up, and you're like, hey, you know what, running this big cluster is a big pain in the butt. Then you can rent it instead.
Okay, I gotcha.
That's the core business model.
Yeah.
So, and then we're doing continued development work as well. I mean, like we're building things like Redis Graph.
Mm-hmm.
That was built almost entirely by Redis Labs. It's open source, so I think we've gotten some help. But
Sure.
We have a team of developers that work on Redis Graph, for example,
Sure.
and other modules to extend Redis.
That's cool.
Yeah, so that's how we make our money. And the open source Redis is the open source Redis, and it'll be the open source Redis. You can use it just like people are using it today.
Sure. That's cool. All right, we have meandered around conversations, mainly WebAssembly and graph databases. Anything else we should cover off on?
Well, I mean, I'm mildly prepared to talk about probabilistic data structures, but it's not that important. We can save it for a future talk.
There you go.
Unless you want to go further, I don't know how long these usually last.
We'll cap it here. We've been at it for a little over an hour now, so we'll be respectful of people's time.
Yeah.
But I do want to, before we end it, I do want to just acknowledge you a bit and thank you for the time and support that you've given us. I know that you're very active in the community. You've been to TC a number of times and spoke, and just thank you for putting yourself out there and doing it, and helping everybody out. I think it's important, especially times like these.
Well, and frankly, it's fun. You're supposed to share, right?
Yeah.
I mean, isn't that what our mothers told us when we were little?
They did.
So that's what I'm doing.
That's right.
So,
you had to cut the
I'm
cookie once, and then your sister got to grab whatever piece that she wanted.
Yeah. One divides, the other chooses.
That's right. How can people get a hold of you?
So the easiest way to get a hold of me is probably to hit me up on Twitter. My Twitter account is my name. It's Guy Royse. That's Royse, not Royce. I have I like to joke it's the Appalachian spelling because my grandfather was from Eastern Kentucky. So, but it's on Twitter, and you can go to GuyRoyce.com. And there's links to all my social media. But I'm most active on Twitter. Been getting into Discord a lot lately.
Yeah.
It's
funny how Discord is picking up.
Yeah. Well, it's snappier. It's just got. Man, I hate to diss Slack because the people at Slack are awesome. I mean, have you ever read the change notes?
Oh yeah.
Or the release notes?
Yeah, they're epic.
They're delightful.
Yes.
They're great people. But Discord is just a little smoother, and it gives me more control. And so I've been slowly, and the authentication model is a lot better. I have one account, and then it just works on all servers. Whereas,
shocking.
I have an entire section of 1Password dedicated to Slacks.
Yeah. Yeah.
So, and so I'm on Discord quite a bit as well. Also, I'm just my name's not very common, so the reality of it is, if you type Guy Royse into Google, it will find me. And you'll find the social media platforms I'm on.
And you're in our Slack,
Twitch as well. Yeah, yes, I am.
You're in our Slack.
If you at me, I will respond. I do go and check it every day. Sometimes I scroll kind of quickly, but I try to keep current. So, but if you at me, I will definitely respond.
Yep,
and I'm here on Twitch as well.
Yeah, that's what I was gonna say. And you're streaming. When are you streaming?
Monday nights from 7 to 11 Eastern time. I stream. Usually, I'm working on Redis Mud, which is a multi-user dungeon. I think multi-user text-based Zork.
Okay.
It's backed with Redis Graph, actually, because it just lends itself so nicely to that problem, and it's fun to play with. On Fridays from 2 to 4 Eastern time, I'm usually streaming. That varies. I've been playing around with Redis AI a bit. I sometimes do Redis Mud. Last time I streamed, I was playing around with Redis Graph, and I was serializing Java objects to graph queries. My thought was, hey, if we could take like a complex object graph in memory,
Yeah.
and turn it into an object graph, into a graph database, I could then query that graph in ways that I couldn't query my objects in memory.
Right. That's
and
interesting.
Get back the object I want, and then throw that graph away. And so I was calling it ephemeral graph.
Yeah.
And create just a throwaway graph for just query purposes, and then pull it back out. And so I was playing around with that concept. I don't know if that's a good idea or not, but I thought it was an interesting idea.
Yeah.
And so I played with it
Yeah.
on stream. So that's the kind of stuff I tend to do on Fridays. Unrelated to anything technology, on Wednesdays I'm going to be starting a stream where I run a D&D game with several people that are also streamers, because why not? That'll be every other Wednesday. It's a big heavy metal themed game with like a heavy metal themed Dungeons and Dragons, and so we're going to have mascots from heavy metal bands be the bad guys that they have to fight. And
Nice. Very nice.
so it should be fun.
Yeah.
So I'm getting my nerd on stream. So.
There you go. All right. Well, Guy, thank you again for today, and everybody who's on, thanks for hanging out. And
Yeah, thanks for hanging out.
we'll get this up on the YouTubes, and we'll go from there. So thanks a lot. I appreciate it.
You're welcome. I hope everyone found it useful.
Absolutely. Thank you for watching, and we'll see you next time.
Yeah. Catch you later.